Alright, so what I'm going to do is I'm going to record a video. This is going to basically break down your lab. The overall idea of a lab in AP Chemistry is to reinforce what we learn in class. So I really don't want you to stress. I mean, the chances of you getting a bad grade on your lab are very slim as long as you basically get the details right, make sure it's in the correct format, and be able to explain. The most important thing is what you learn from the lab. That's really the focus. I mean, overall, and that's what you have to keep in mind. No stress. All right, here's the rubric that I'm going to use to grade it, so I'm going to show you this. First of all, every lab should have a title that's descriptive, so just don't say Experiment 5, although we don't use them straight out of a lab book anyway. It should basically be descriptive, so the title should be descriptive. You always want to have the date for the lab that you perform the experiment. Keep in mind the first point you get on the rubric is keeping your front of your lab book. Every time you do a lab, you should update the table of contents, so I check that off, you get 1 point. Because it's a lab, we can't really use pencil or whiteout, so really what you want to do is only black or blue ink, same thing that they would do at a college level, you get 1 point for that. Appropriate title's descriptive, the date when the laboratory was performed, you get 1 point for that. Purpose. The purpose is stated in a complete sentence. It's basically a real brief statement, it should be one sentence, real specific, and look at the objectives of the lab. It should be pretty obvious when you walk into a laboratory that you know pretty much exactly what you're doing. And you should be able to basically state that in a quick, specific sentence. You get 2 points for that. Next, pre-lab questions. If we do have pre-lab questions, those are always going to be done on turnitin.com. Turnitin.com is basically what you're going to be doing with that. So the pre-lab questions do not go in the notebook. Okay? So make sure those would be on turnitin.com. You would turn in any pre-lab calculations there. They don't appear in the pages of your notebook. Next, procedure. A brief description. The idea is on the AP exam, you're supposed to be able to explain how to set up an experiment. In fact, either question 2 or question 3 on the AP exam, they're going to ask you how you would construct an experiment. So it's important that you use not necessarily the lab manual, but you'll basically use the instructions that we have for the lab to basically include a brief statement of the method. Don't include copying word for word, but it should be specific and brief. The idea is someone should be able to read this pretty quick, and it's been modified. The key parts are boxed. So if it tells you to measure out 10 milliliters of sulfuric acid, for example, what you would do is when you write it out, you would basically box it or double box it. That way, when you write everything out, you can easily see any value that you need to measure out in the lab. It's kind of like highlighting something, but in a lab book, we don't highlight, so what you would do is double box. So any key parts involving amounts, time that you have to do something, the temperature at which you want to do something, anything like that that's real specific detail, you want to box. It needs to be written as numbered steps, so it would be 1, 2, 3, 4, 5, all the way through. Do not write it as a paragraph, and again, make sure it's real specific. Don't copy it word for word. I would even put it in your own words so you can think about exactly what you need to do. And you're going to get 2 points for writing the modified procedure with the parts boxed. 1 point is if it's numbered steps, not in paragraph form. Next part. Key is with your results, you want to make sure they're neat. Any kind of observations, we don't do that many, but you basically, a qualitative observation, you are going to state specifically what you see. Again, we don't do that often. We really focus more on data. The data needs to be neatly arranged in tabular form. Now, we have desktops at all the lab stations, so what I would expect is you would just use Excel because it's easier. You want to make sure you include units of measurement. So when we start talking, here's the rubric right here. You make sure you get 1 point for having the units. You want to measure everything in correct significant figures, and then you want to have basically all the data. You get 2 points for the whole thing. Anything that you don't have, like correct sig figs or units, there would be a deduction. The table, copied by hand, actually, we could basically edit that. The idea would be, at this point, for college, you want to do it in Excel. Titles and list all the variables and the units on everything. Units on everything. Charts are not split in between pages. What that means is if you make an Excel chart, it should fit on basically 1 page. You shouldn't split it over 2 pages because it's hard to basically identify trends in the data. And overall, if you're using Excel, it shouldn't be a problem. But if you decide to handwrite it, which I would not suggest, make sure that it is very neat, use a ruler and all that stuff. So if you're doing it by hand, which again, I would say we use Excel because that's what they're going to expect you to do in college, you would basically make sure they're appropriate size, or use a ruler, make sure you give titles and label all the variables. All the key things are right there for you to read over. Calculations. Calculations are important. Remember the trifecta. So you need to basically, any calculation you do, you have to show the formula first with the units, then same thing we do in class in the homework. Label what is being calculated. When you look back at your lab notebook, you should always be able to decide what it is you just calculated. So the first thing is important is you put titles on all the calculations. So if I'm titling the density of something, let's say the density of a cube or something, and say we're doing a lab on density. The density of a cube, I would write out the title, whatever my calculation is. Wow, that's a horrible underline. I would double underline it, and then I would put the formula. The formula is going to be density is equal to mass over volume. Then I would put the numbers. Now, if you're doing multiple density calculations, right, you can show basically the setup. You only have to write the setup once, and then you would write the numbers for each of them. After that, you wouldn't have to show the setup each time for each successive calculation. But anytime you do a calculation, you have to have a title on it. You get 2 points for that because that goes back into organization. In this case, you get 2 points for setups on all your calculations. So for every calculation, if we're doing a Beer's Law calculation like the Gatorade lab, remember like this, the Gatorade lab Beer's Law was A equals EBC. You would have basically your setup, plug in your numbers, 2 points for that. All key calculations have to be shown. Like an example for the lab that you did, I think it was actually 4, but for the 3 unknowns that you did, the first one was a sample. You do Q is equal to MC delta T, and then you would show 2 grids for the cost of each warmer, and then the cost efficiency ratio. Everything you're basically supposed to be calculating in a lab, whatever the purpose of the lab is, you would get points for. So in this case, it's 5 points. Units, 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 that goes back to the trifecta. You get 2 points for having all the units, and then you get deductions. Conclusion is very simple in chemistry. It's right to the point. It should be one sentence, and it should be very specific. Like if the purpose in our Gatorade lab was to calculate the concentration exactly of how much, what the molarity of the dye was in Gatorade or the exact amount of grams, it should be very specific and precise. So you would say the molarity of the dye in Gatorade was 8.2 times 10 to the negative second molarity, or let's say it was I had 2.14 milligrams of dye in my Gatorade. Make sure it's very specific, and it would always, the idea is whatever your purpose of your lab is, it connects back to your purpose. Next one, discussion of theory. This is basically what did you learn? What did you learn? Every lab that we do connects back to a big idea in chemistry. So in this section, you're telling me what you learned. So what is the concept? What did the calculations show you, or how does it connect? How does the calculations connect to the concept? Maybe the experiment didn't work so well, you could add that, but really you're proving to me that you understand the chemistry. Be detailed, be specific, and if you're not sure, you can always ask me for help. You get 1 point for a clear connection to the chemistry concept. Always start with basically what's the point of doing the lab, and it goes back to something we obviously learned in lecture. 9, experimental sources of error. You always want to think about error. How did error influence the data? How did they make the value larger, smaller than it should be? This is the example of what we call math. They ask you in AP to describe mathematical example of error. Like if you did something wrong or you got a bad value, what will it do to your calculated value? So like Beer's Law, A is equal to EBC. What we did is in our lab, we measured absorbance, right? We measured absorbance. These two are constants, and we used the absorbance to find the concentration. That's basically what we ended up doing. So what happens if you get fingerprints on your cuvette? So let's say you took the cuvette during the Gatorade lab, and you got fingerprints on it, so the absorbance was too high based on the fingerprints. There's error there. You can't just say, oh, the error was I had fingerprints on the cuvette. The trick is for you to explain, if this number was too high, what would it do to my calculated value? Well, based on this equation, mathematically absorbance and concentration are directly related. My concentration value would be too high. So that's what you want to focus on the hand warmer lab. Let's say you made an error in temperature. So you measured the temperature too low for one reason or another. And you may or may not be able to identify an exact error. But the trick is for you to think about it, because on the AP exam, what they do is they will ask you, they'll say, hey, what if this value is off? I think explanation spelled wrong. Wow, that really is a bummer. Anyway, pretend like you didn't see that. Experimental sources of error, you get 1 point for discussing it. You get 1 point for the percent error calculation, and then 1 point for the explanation. I think that's spelled wrong. Whatever. I'm not an English teacher. Next, post-lab questions. If you have post-lab questions, answer them, but these would actually be included in the lab book. You don't copy the question. So you don't have to copy the question, but what you have to do is you definitely have to answer the questions and be specific. And the key thing is, the focus is I don't want you to stress. If you do everything and you put good effort into it, you're pretty much going to get a very good grade on the lab report. My biggest thing is make sure the format is laid out correctly. Make sure you're thorough, labeling everything, trifecta, trifecta, trifecta. You complete all the components. The average lab grades last year were very, very good. So it's not about stressing. It's about make sure you do stuff right. And at the end of the day, I care that you basically learn something from the lab. Because on the AP exam, you're going to have to explain what you did. Like, what did you do? Like, how did you do it? Or what did you do? What did you do? What does it mean? And basically, how do you know from the results? That's the focus of the AP exam. All right? Hope you enjoy your day off. You're going to start on the hand warmer lab. If you have questions, you can always email me. Have a nice rest of your day. And here's a little smiley face for you. There you go. How exciting is that?